Okay, welcome back to the mid-year exam 2020. This is Criterion 5 Solutions, and this is the last question of Criterion 5, question 9. And in this question they ask, using two of Newton's laws, explain why it is a good idea to use a parachute if you jump out of a plane. So let's start off by thinking about what is actually happening if you jump out of a plane. You have the force of gravity acting downwards, okay? And with a parachute, if we want to have a parachute, let's say if we can draw a parachute, something like that. Okay, parachute's going like this. The parachute will provide a drag force, Fd, going upwards. Okay, so let's think about Newton's first laws then in this context. So N1, an object will continue in its original motion unless acted upon, oops, let me see if I can spell properly, acted upon by an unbalanced force. Okay, so therefore a parachute will provide a force to prevent the person continuing at um, at its velocity, or at its the person continuing at its velocity if only gravity were acting on it. Okay. A parachute will provide a force to prevent the person continuing at its velocity if only gravity were acting on it, reducing the overall net force. Okay, reducing overall net force. And if you're wondering why that's the case, it's because F net is equal to Fg, let's say downwards is positive, Fg minus Fd. So the larger the drag force, the less the force will be due to gravity. Okay. All right. So we want to reduce the overall net force and have a soft landing. Reducing overall net force for a soft landing. Let's say that for soft landing. I'm going to do all three forces in case you're wondering how we would answer all of them, but you wouldn't have to do that. Okay, N2, F equals ma. Okay, F equals ma, which is equal to m times v minus u over t. Okay. So, how would we act? So, in this case, I guess would say that something along lines that a parachute, heart attack, will increase time it takes to stop, and therefore decreasing the overall force, decreasing the force of impact. Let's say that impact. We could also say it could also slow down the parachute. Would also decrease the speed of impact, also reducing the force of impact. as the parachutist or the person comes to rest. Yes. Okay, that's because it's initially, when you think about the impact as an event, u is equal to the initial velocity on impact with v being 0. Okay, so the closer u is to 0, the smaller the force. And Newton's third law. Okay, Newton's third law: for every action there is an equal and opposite reaction. Maybe hard to say this one. For every action there is an equal and opposite reaction. It's not probably exactly what you want to say these days. It's probably a better way of saying this law. Newton's law: for every action there is an equal and opposite reaction. So the let's see, for a parachute. Okay, I'm just going to restate what we said before. So a parachute, this is probably not satisfactory. You probably want to focus on the first two laws in this case. A parachute will decrease the action force on impact. So person on Earth, which will decrease the reaction force. Earth on person. Something like that. In these ones, you want to state the Newton's law that you're applying. So in each of these, I've stated what the Newton's laws are, just to show that I know what they are, and then I've tried to relate it back to the problem at hand. So the most satisfying answers would be Newton's first law and second law in this case. Newton's third law is a bit wishy-washy, but you could probably still get away with it maybe if you've got a generous marker. Okay, so that is the mid-year exam 2020 for Criterion 5. So well done if you for getting this far. All right, see you in Criterion 6.